All right, here to talk about the Half-life Lab 4.8a. Let's see. So what we're going to do is we're going to look at how atoms decay and the patterns of groups of atoms decaying, not just a single atom decaying. So I want you to be thinking about what is an isotope, give an example, what causes an atom to undergo radioactive decay. Think about that for a second while I deal with my daughter here. All right. So what we're going to do is I'm going to do the version of the lab here that doesn't require the physical materials. I'll do it online so I can show you what I'm doing and we can talk about it. Here's how this is going to look. I'm going to go through this process. So I'll talk about that. I'm going to move this over here and set that up. So I've got this, and hopefully you can see all of that now. So we'll go through this process. I've got 100, I decided nickels just because those fit the best. Although now that I've gone to a half screen, it's probably not going to fit the best. So we'll go with what we got. And we're going to record stuff on our data table. So here's the idea. At the beginning, we have times 0, we have 100 thallium. So we have 100 coins here. 100% of the thallium is remaining. So I'm going to flip the coins. And we'll see what I have here. So they are in groups of 5. Good, so I can see it. So I'm going to count the number of heads that I have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So far 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. This is terribly exciting, I would bet. 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58. 58. All right. So that means when I come back here, I had 58 that flipped over as heads. So those don't disappear. They turn into something else. So remember when we watched an element go through radioactive decay, it didn't disappear. It became another element. So we had 58 become paperclipium. That means I've got 100 minus 58 is 42, so I've got 42 thallium left. So that would be 42% of the original. 42 divided by 100 is 42%. So now let's go back here. We're going to go back. We're going to change this number to 42. And we're going to flip them. All right. Number of heads again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So here's where it gets confusing. I have 2. I now have a 58 plus 19, so that would be 77, which means I've got 23 of these, which is about 23%. So now I'm going to move on to year 3, and I'm going to come back, 3. All right, I'm going to flip them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so I have 10 more. So now I go to 87 of these, and 13 of these, and 13%. All right, so back. It doesn't like that. Okay, so I'll just flip down here. 13. Flip the coins. 1, 2, 3, 4, 5. All right. So now at 92, which means there's 8. This is after 4 years. It means I've got 8% left. Keep forgetting. Doesn't like it when I try and get down to these short numbers. So 8. 1, 2, 3, 4, 5 of them flip. So that means I'm now at 97. Down to 3. And it's been 5 years at this point. So I've got 3% left. Back. 3. Flip coins. 1 head. So I'm at 98. 2. So after 6 years. 2%. Back. 2. Flip coins. 2 heads. So now at this point, after 7 years, I have none left. I've got 100 paper clip-ins, 0% of the thallium remains. So it took 7 years for it all to disappear. I'm going to flip back to this now so that we can take a look at it. All right. How many years did it take thallium to have only 50% left? Well, look back at this, you can figure that out. Take the number that's closest to it, right? So if you're like, well, which one do I take? Which one is closest to 50%? And then I want you to graph your data. So notice this is by 2 years down here. So at 1 year we had 42%, so I might draw something here. Be like, okay, so 1 year it was like right there. And then at 2 years it was at like 23, so that might be like right there. Right? And think about drawing that in. And then below we have a data graph from what happened last year. And I'll be honest, this wasn't last year in my class, although my class was very similar to this last year. It looks a little like this. So think about how did your data compare to the class data. Thinking about what did the pennies that landed as tails, what do they represent? And what do the ones that land as head represent? And at what point is there only half of the thallium remaining? Where did it go? How long did it take to go from 50% to 25%? 25% is half of 50. What do you notice about the time it took for 50% of thallium to change compared to how long it took to lose half again to go from? So look at the amount of time it takes to go from 100% to 50% and the amount of time it takes to go from 50% to 25% and compare those. And then compare that to how long did it take to go from 25% to 12.5%, which is half of 25. And then you're going to take this and think about, did the amount of time it takes for half of it to decay change or stay the same? And remember, we're thinking about half of what is left. So the amount of time it takes to go from 100 to 50, the amount of time it takes to go from 50 to 25, the amount it takes from 25 to 12.5, from 12.5 to 6.25%, right? And then think about, I want you to come up with what you think is the correct definition for half-life and why. Explain, is it a measurement of time or a measurement of the amount of something? And then try and figure out that question right there. And I will link this video here again right after this one in the YouTube playlist. All right, good luck.